Hello friends, welcome to civil engineering exam. Today we are going to see the problem related with design of cantilever slabs. So the problem is design of cantilever chajja slab projecting 1 meter from the support using M20 grade concrete and Fe415 HYSD bars. Adapt live load as 3 kilonewton per meter square. Okay, so this is the sunshade or balcony. Okay, so we can provide the cantilever slab. Okay, so now the given data is L equal to 1 meter. So then live load is Q equal to 3 kilonewton per meter square. So then FCK is given, that is equal to 20 Newton per mm square. So then Fy value is 415 Newton per mm square. Okay, so these are all the given values. So now we can find out the tau BD, that is equal to 1.2 Newton per mm square. It's taken from the IS456 because of the M20 grade concrete. Okay, so now we can take first thing is we can find out the depth of slab. So depth of slab, so now span by effective depth equal to 7. So we can use from the IS456. Okay, we can take it from the IS456. So now depth equal to span by 7. Okay, so now the span is 1 meter. So now 1000 mm divided by 7, that is equal to 142.8 mm. Okay, so now we can take d equal to, so small d effective depth equal to 150 mm. Okay, so now overall depth equal to, we can provide the 25 mm cover, so the overall depth equal to 175 mm. Okay, so 150 plus 25 mm cover, that is equal to 175 mm. Okay, so next thing is we can provide the slab as the gradually reduced to 100. Okay, so now here is the depth of slab is 150, here the depth of slab is 100. Okay, so 150 mm and 100 mm. Okay, so generally we are providing the sunshade like this. So we can provide in one side is 150 and gradually reduce it to 100 in the another side. Okay, so now we can find out the loads. So first thing is dead load. So now the dead load is 0.5 into 0.15 plus 0.1. So we can take in the meter. Okay, so here is the upper side, here is the lower side, into 25, that is unit feet of concrete. Okay, so now we got the value of 3.125 kilonewton per meter. Okay, so for 1 meter span we can take 0.5 into 3.125 kilonewton per meter. Okay, so next thing is live load. So live load for 1 meter, so live load for 1 meter is 3 into 1, that is equal to 3 kilonewton per meter. Okay, so here they are given is a kilonewton per meter square, so we can take in for 1 meter span. So now we got the value of 3 kilonewton per meter. Okay, so next thing is finishes load. So finishes load we can take an as 0.875 kilonewton per meter. Okay, so now the total load will be equal to 7 kilonewton per meter. Okay, so next thing is factor load. So that is ultimate load W U equal to 1.5 into W, that is 7, that is equal to 10.5 kilonewton per meter. Okay, so this is the load we can use. Third thing, moment. So now we can calculate the moment. So the moment mu equal to, for cantilever slab, moment equal to W L square divided by 2, that is equal to 10.5 into 1 square divided by 2, that is equal to 5.25 kilonewton meter, that is equal to 5.25 into 10 power 6 Newton m. Okay, so next thing is shear stress, VU equal to W into L, that is equal to 10.5 into 1, that is equal to 10.5 kilonewton. We can convert into Newton, that is 10.5 into 10 power 3 Newton. Okay, next thing is we can calculate the reinforcement. Before reinforcement, we can check the depth. So check for depth, that is mu limit equal to 0.138 FCK B D square. Okay, so now we can substitute all the values over here, that is 0.138 into FCK value is 20 into B value is 1000 into D value is 150 square. Okay, so now we got the value of 62.1 into 10 power 6 Newton mm. Okay, so now our moment is 5.25 into 10 power 6, that is less than of 62.1 into 10 power 6. Okay, so now mu is less than of mu limit, so this is the under reinforced section, so depth is safe. Okay, so now we can provide the reinforcement. So the reinforcement details, the formula is mu equal to 0.87 Fy AST into D into 1 minus AST into Fy divided by FCK D D. Okay, so now we can substitute all the values over here. So the moment is 5.25 into 10 power 6 into 0.87 into Fy value is 415 into AST we have to find out into D values 150 into 1 minus AST again we have to find out into 415 is, so that is Fy is 415. Okay, so divided by FCK is 20 and B value is again 1000 into D value is 150. Okay, so now solving this we got the value of AST equal to, that is 105 mm square. Okay, so this is the area of reinforcement. So hence we provide 10 mm diameter reinforcement at 300 mm center to center. Okay, so now the new AST is we provide is 262 mm square. Okay, so next thing is anchorage length. So now we find out the anchorage length. So anchorage length, the formula is LD equal to 0.87 Fy into diameter divided by 4 into tau BD. Okay, so using IS456 we got the formula. So now we got the value. So 0.87 into Fy value is 415 into diameter we are using 10 mm dia bars divided by 4 into tau BD we taken 1.2 into 1.6. So now we got the value of 470 mm. Okay, so 470 mm is the anchorage length. So this is a method we can solve the problem. Again we will see next video. Thank you.